How do main sequence stars achieve stable balance? Imagine a star like our Sun shining steadily for billions of years. How does it keep that perfect glow without collapsing or blowing apart? The secret lies in a delicate balancing act happening deep inside. Main sequence stars stay stable through a process called hydrostatic equilibrium. This means the inward pull of gravity pulling everything toward the center is exactly balanced by the outward push of energy produced in the core. When hydrogen atoms fuse into helium, they releases a lot of energy. This energy creates pressure that pushes outward, fighting against gravity's squeeze. If the fusion process speeds up just a little, the star expands. When it expands, the core cools down, which slows the fusion. That cools the star and keeps it from getting too big. On the other hand, if fusion slows, the star contracts. When it contracts, the core heats up, speeding up fusion again. This feedback loop acts like a natural thermostat, keeping the star's size and energy output steady over millions or even billions of years. There are two main types of balance at play. The first is hydrostatic equilibrium, which is the balance between gravity pulling inward and the pressure from fusion pushing outward. This prevents the star from collapsing or expanding uncontrollably. The second is thermal equilibrium, where the energy generated in the core matches the energy lost from the surface. This keeps the star's temperature and brightness consistent. The size and mass of the star determine how long it stays in this stable phase. Smaller stars like the Sun mainly use a process called the proton-proton chain reaction to fuse hydrogen. Larger stars relying on a different process called the carbon-nitrogen-oxygen cycle. Both reactions are very sensitive to temperature, which is why the star's core temperature stays tightly controlled. Understanding this balance is important because it explains why stars like our Sun last so long and remain stable. It also helps scientists predict how stars evolve over time and how they influence their surrounding space. This knowledge is key to understanding our universe and the life cycles of stars beyond our solar system. In short, main sequence stars keep their stability through a finely tuned interplay of gravity, pressure, and nuclear fusion. This balance allows them to shine steadily for billions of years, providing the light and heat that make life on Earth possible.